Okay, let's get a little bit more into detail about how electrical circuits are actually designed. Now, remember the location of outlets and switches does sometimes depend on furniture location. So the designer will often show outlets and switches and things like that on their drawings. And you can also approve the appearance of switch plates and outlet covers and that sort of thing. So the electrical circuit is a loop, and electricity must have a complete path from source to device and back to source. So it has to continuously go in like a circle. When the switch is turned off, it's interrupting the circuit. When it's turned on, the alternating current flows both ways in the loop, changing direction 60 times per second. And remember, the voltage coming into the home is around 120 volts. So the circuit will have three wires: the hot wire, which is black, the neutral wire, which is white or gray, and the ground wire, which could be either green or bare copper. The hot wire will carry the electricity from the utility supply, and this is always charged, waiting to deliver the juice. But unless it has a way back to the source, it won't deliver. The neutral wire will close the loop and provide the way back. When you flip on the switch, you are essentially connecting those two wires, creating the circuit. Now, a conduit is typically used to carry many wires together. It's basically a tube to house wires, most often used in commercial situations. Grounding is essentially using the earth to complete the loop. So if you receive a shock, you must not only be touching the source of electricity, the hot wire, but you must also be grounded. When you touch the hot wire, your body acts as the neutral wire and completes the loop through the ground you are standing on. Essentially, grounding is the process of the electrical system using the earth as an alternate path for the electricity for safety purposes. The neutral wire is connected to the ground at the main service panel. It goes into a copper-coated steel rod that is driven deep into the earth. Now, there are three features that make electrical systems safer, and these have all been around more in recent years. If you live in an older home, you may see that your outlets only have a place for two prongs. That's because the equipment ground hasn't been around forever. Basically, what that is this third prong you see, the neutral wire, solves the problem of the electrical leak by providing a good path back to the main service panel. It does not ordinarily carry current, and now all outlets that are installed must be of the grounded type. The ground fault circuit interrupter, or GFCI outlet, is what's used in damp or wet areas to prevent shock. It will instantly detect misdirected current and shut off the circuit. Code requires that these be used in all outlets outside, in bathrooms, kitchens, break rooms, pool areas, bar areas, and laundry rooms. And lastly, polarized plugs are plugs that only fit into the outlet one way. This assures that the neutral wire within the cord will connect with the neutral wire in the electrical system, and the hot wire will attach to the hot wire. All right, so receptacles and switches. First of all, let's talk about the outlet box. This is basically a metal box designed for making connections to a wiring system. It's used for outlets, switches, light fixture connections in walls and ceilings. So this is what is housed behind the drywall, holding all the wires. A junction box, or a J box, is also a metal box used to enclose wires, but these enclose the meeting or the junction of electrical circuits. A receptacle is a fancy name for an outlet, and you'll kind of hear me go back and forth between the two. The technical name is actually convenience receptacle. Now, they're rated to hold up to 250 volts, but they're only supplied 120 in residential situations. They must be grounded and polarized, as I just mentioned, and they're typically mounted 12 to 18 inches above finished floor. If they need to be higher than that, you must note that on the plan. So every time you see an outlet on the plan and there's no note next to it, the contractor will know that that's going to be a standard height outlet, and he's going to place it, roughly 1.5 feet off the ground. However, if you want your outlet to be above a counter, then you need to note plus 36 inches, plus 40 inches, plus 48 inches, wherever it may be that you want that mounted. Now, switches are also called contactors, and it's basically a simple device that separates the neutral and hot wire to open and shut the light off. A three-way switch is actually two switches that operate the same light at different ends of a hallway or stairway. The interior designer will typically indicate the location of switches and receptacles on their drawings. All right, so here are some other design considerations and things that you should know. First of all, there are some general requirements. Every room, hall, stairway, entrance must have a lighting outlet or a light operable by a switch. So if you design a bedroom with no ceiling fixture, then you must have an outlet that's called a half-hot outlet, where part of that is connected to a wall switch. So you could plug in a lamp, flip the switch, and the light would turn on and off. No point on a wall can be more than 6 feet from a standard outlet. So that's why we place outlets typically every 12 feet. If there's a wall that's wider than 2 feet, even if it's 4 feet from another outlet, it must have its own outlet. Now, walls above counters, so anytime you have a countertop in a kitchen, in a break room, wherever, you have to have an outlet every 2 feet. If you have a piece of wall longer than 12 inches, it has to have an outlet. Electrical ranges require a special high voltage appliance outlet. That has to be noted on your plan. And all outlets above the counter must be GFCI rated. So if you have the range outlet and it's down on the ground behind the stove, it doesn't have to be GFCI rated. The outlet for your refrigerator, which is on the wall towards the ground behind the refrigerator, does not have to be GFCI rated. All right, bathrooms. All switches and outlets cannot be accessed from the shower or tub, and they must all be GFCI. Bedrooms. You definitely want to think about having 2 outlets flanking the bed for lamps and alarm clocks and things like that on the nightstand. And if there's no central air conditioning system, each bedroom should have an appliance circuit for a window AC unit, one of those high voltage outlets. Again, you also want to think about, again, putting a half-hot outlet in bedrooms, because typically you don't want to have that overhead lighting in a bedroom, and that way you can operate lamps from the wall. A dryer, like a range oven, will also require the 240 volt major appliance circuit. And then all the outlets other than that in the room, in the laundry room, should be GFCI. Every bedroom should typically be equipped to serve as a home office. Again, that's getting a lot easier today because for the most part, you can put a wireless router in one bedroom and the entire house then receives internet. So that isn't as crucial as it used to be, but it's definitely something to consider. And there are some clients you may have that are completely not tech savvy and aren't into the wireless thing. Maybe they think it, causes brain cancer or something, and they may want to have each bedroom wired. All right, that's it for this week. Pretty quick, huh? I suggest now you read through the book, because there is a lot of information that I didn't put into the lectures, and then move forward with your homework.